All right, guys, this video, we're going to move right to the next problems where we're going to apply the rational zero theorem. So number 3, you can see it says find the rational zeros, right? That's all at once. Now, the other thing I didn't mention in the last video is that you can have zeros that are irrational, like pi. It could be a long, ugly decimal. That's where this list is not going to help us out. All right, it's kind of like your cue for this problem for number 3. You're going to see what happens. This is our equation. Our degree is 3. All right. Now, I can't factor anything out, right? It's not a quadratic, and I'm not given any zeros, so I have to start with this plus or minus p over q. So let's get the possible rational zeros. Let's put plus or minus, right? And then remember, p is all the factors. I can't draw a straight horizontal line. But it's all the factors for the constant, which is just 1. So we're just going to have 1. And then the bottom is all the factors for the leading coefficient, which is just 1. So this is a really short list. So I only have 2 possibilities that could give me a rational zero, or excuse me, a possible rational zero is plus or minus 1. So I am just going to use synthetic division for 1. If it doesn't work, meaning I don't get 0 for the remainder, then I'm going to use -1. So let's start off with 1. I'm going to put the coefficients here. So I have 1 x cubed negative 3x squared. Now there's no x, so this sometimes is a sticking point. So put 0 and then put 1. All right, so this is a real quick process. I bring down the 1. 1 times this one is 1. -3 plus 1 is -2. -2 times 1 is -2. 0 plus -2 is -2. -2 times 1 is -2. And then we add, we get 1 plus -2, which is -1. That's the remainder. So that remainder is not 0. So this is not a 0. So let's try -1. All right, put the same coefficients, 1x cubed, -3x squared, 0x, and 1. All right, let's bring down the 1. -1 times 1 is -1. Add -3 and -1, we get -4. -4 times -1 is 4. 0 plus 4 is 4. 4 times -1 is -4. And look, this doesn't work either. 1 plus -4 is -3. So that's not a 0. All right, so what does that mean? I tried all the possible rational zeros and they didn't work. 2 things this could mean. All right, it could mean that all the zeros are imaginary, where you have the I in it, or the zeros are irrational. Now, the only way you would know is by graphing it. Now, I'm just going to put this a rough sketch. If you actually graph this, okay, if I put this in and I graphed it, you would see it would hit the x-axis. It looks something like this. It hits the x-axis 3 times. And if you actually use the features on the TI Inspired to find these zeros at these 3 points, they all would be long, ugly decimals. They would be irrational. All right. Now, to be honest with you, probably the problems that I give to you, that's not going to happen a whole lot. But I just want you to understand that you could try something on here with synthetic division on that list, and it might not work out. All right. All 3 of these are irrational. Okay, just kind of abbreviate it right there. All right. Okay, let's move on. Let's do number 4. And then that'll be it for this video. This is really the same thing. Now, this one, it says find all the real zeros. All right. So, okay, so let's start with our list. And it's in standard form, so I don't have to rearrange terms. Starts with the highest exponent, goes down to the constant. So when I list the possible rational zeros, I don't have plus or minus, and then the top is always the constant. Well, factors for 2 are just 1 and 2. And then the bottom, got another prime number. So we just have 1 and 3. All right. See how if I give you these problems where you have to do the whole plus or minus p over q, I really don't give you a whole lot of possibilities. All right, so then if I apply it and I divide, different color here, use the second green. So if I take 1 over 1 is just 1, so it's plus or minus 1. 1 over 3 is just plus or minus 1/3. 2 over 1 is just 2, so we have plus or minus 2. And then this 2 over this 3 is plus or minus 2/3. All right, so 1, 2, 3, 4, there's 8 possibilities. Here's one thing I would always do, guys. Always start with 1, right? It's the easiest one. You can get through it very quickly. Let's try 1 for this. All right, let's just put in these coefficients. So I have 3, 4, x squared, negative 5x, and negative 2. Okay, make sure you have space for this line. All right, bring down the 3. 1 times 3 is 3. 4 plus 3 is 7. 7 times 1, 7. Negative 5 plus 7 is 2. 2 times 1 is 2. And look, this one works out because negative 2 plus 2 is 0. All right. So what I've proven, kind of two things. I've proven that x equals 1 is a 0. And then also the factor theorem. This is going to enable us to get the last two zeros. If this one is a 0, then its factor for it is x minus 1. And then you could say its quotient when you use synthetic division. Since we started with x cubed, after you use synthetic division, the degree goes down by 1. So the other factor for this is 3x squared plus 7x plus 2. All right, 3x squared plus 7x plus 2. And we've seen this before. You want to use synthetic division until you can get this bottom line to be a quadratic. And we already have this. All right, now what should we do if we have this quadratic right here? Always look to factor it. And if it doesn't factor, yes, we're going to use quadratic formula. I believe this one does factor though. Okay, this is where you have 3x for the first term. The other term has to be x. And our factors are for 2 are 1 and 2, so it's just a matter where we put it. Okay, and I believe it's just 3x plus 1 and x plus 2. If you FOIL this out, you're going to get this for it. Okay, because if I did my outer terms, 3x times 2 is 6x. Inner term, 1 times x is x. When you add that with 6x, you get 7x. All right, so I have all my factors. So the zeros I have are 1, which I already proved. And then when I set these equal to 0, you would subtract 1 and divide by 3. So it's negative 1/3. And then if x plus 2 is a factor, negative 2 is a 0. So if you actually did synthetic division for negative 1/3 and negative 2, which, look, they're both on the list, you would get the remainder to be 0. All right. Now, this was a good one where you did synthetic division and you got the 0 right away. That's not always going to happen. So what I would recommend is have an eraser with you, right? Don't just be using a pen with no eraser because then you're just going to be constantly scribbling stuff out. This is trial and error, right? You're just going to figure out which one of these is going to give you a remainder of 0. Then you want to get this down to quadratic, and then this you could factor. If it doesn't factor, then use quadratic formula.